Good morning, fourth graders and parents watching. I hope you're having a thankful Thursday today. Let's go ahead and get started by reviewing some of our temperatures. I will show you the name and you give me the temperature, the degree symbol, and the scale. Here we go. 212 degrees Fahrenheit. 32 degrees Fahrenheit. 100 degrees Celsius. 98.6 degrees Fahrenheit. I hope you're having a normal body temperature today. 0 degrees Celsius. 37 degrees Celsius. 212 degrees Fahrenheit. Last one. 32 degrees Fahrenheit. Now, let's see if you know it the other way around. I will show you the temperature. You tell me what that temperature signifies. The normal body temperature, Fahrenheit. Freezing point of water, Fahrenheit. Boiling point of water, Celsius. Boiling point of water, Fahrenheit. Normal body temperature, Celsius. Freezing point of water, Celsius. Last one. Normal body temperature, Fahrenheit. Okay, how'd you do? All right, we have a big review day planned today. We're going to be reviewing lots of fractions, not just dividing fractions, but that's what we're going to start with since we've been doing that this week and last week. That's our new thing recently. Okay, let's go ahead and open up that math book to our pages for today, and let's get started with section 1, letter D. Remember, we can only divide a fraction by a fraction. Here we have two mixed numbers. So let's do our backward C for both of these. Multiply the bottom, add the top, keep the same denominator. We should get 3 halves for both. Remember, it's really important to write down the fractions first before you start your keep, change, flip. Now that we have a fraction on both sides for our dividend and our divisor, now we can begin our keep, change, flip. Keep the first fraction exactly the way it is. Change your sign from division to multiplication. Flip the final fraction. Remember, flip means to invert. You're turning it upside down. It should be 3 halves times 2 thirds. Are you seeing what I'm seeing? We can cancel everything. Everything will become 1. 3 divided by 3 is 1, and 2 divided by 2 is 1. 1 over 1, and that equals 1 whole. Circle that as your answer. Moving on to section 2, letter E. We are making equivalent fractions. Remember, one might look smaller and one might look larger, but they mean the exact same thing. It's kind of like if I were to give you $1 bill or 100 pennies. Their value is the same, even though they look completely different. One looks like it's a lot more than the other. Their value is the same. The rule for this is whatever we do to the denominator, we must do to the numerator. So what can we multiply 6 by to give us 30? 6 times 5. Remember that rule and apply it. Whatever we do to the denominator, we must do to the numerator. So if we multiply by 5 down below, we must multiply by 5 on top. 5 times 5 is 25. So I have a question for you. What is larger, 5/6 or 25/30? Neither. They're exactly the same. They're equivalent. Equivalent means equal. Even though they look differently, their value is the same. Kind of like us. We all look different. We sound different. Some of us are tall or short. But in God's eyes, we all have the same value. Let's go on to 3F. 3F is reducing. Remember, reduce means to divide to the side. So 8/12. I need to think, what is the biggest number that I can divide the 8 and the 12 by? We always want to start by trying the numerator. If that doesn't work, we know it will be a number less than the numerator. In order to figure out which number that is, we need to remember what the factors are for that numerator. The first factor is always 1. The last factor is always the number itself. Since 8 is an even number, the next factor will always be a 2. 1, 2, 8. Okay, so 1 times 8 is 8. 2 times what gives us 8? 4. Our factors are 1, 2, 4, and 8. What is also a factor of 12? If you're thinking 2 and 4, you're thinking correctly. However, which one do we choose? We always want to choose the biggest one possible. The bigger one is 4. Our same rule applies here. Whatever we do to the top number, we have to do to the bottom number. Otherwise, it's going to be crazy. Okay, they'll think that it's unfair and they'll start a riot. So 8 divided by 4 is 2. 12 divided by 4 is 3. This is our reduced answer. I know it's reduced because it's in counting order. That's one of the little tricks of the trade. If you see a number that's in counting order, you know that that is the smallest that number can possibly be. So I'm going to ask you the same question I asked for 2e. Which fraction has the greater value, 2/3 or 8/12? If your answer is neither, good job. They are equivalent, but sometimes it's just easier to work with the smallest numbers possible. That's why it's important that we know how to reduce. 4e. What type of number is this? I'll give you a hint. It's not a whole number, even though there's a whole number there. And it's not a fraction, even though there's a fraction there. When we have a whole number and a fraction side by side, what do we call that? A mixed number. For this section, we're changing the mixed number to an improper fraction. That's where we do our 3 steps: multiply the bottom, add the top, keep the same denominator. We also refer to this as the backwards C. It's like you're writing a C in reverse. That helps us to remember to start here. 3 times the whole number, 11, is 33. Plus 2, 35. Keep the same denominator. Nicely done. Go to section 5, letter G. Now this has a lot of different kinds of problems with fractions, but I wanted us to look at letter G specifically because it is subtracting a mixed number from a mixed number when their denominators do not match. We call them uncommon. The first thing that we have to do is to make them common. 3 and 5. What is the larger number? 5. That is the number that we are going to be counting by. We're going to count and stop. Ready? 5. Stop. If we count by 3s, will we get to a 5? No. Let's keep counting. 10. Stop. If we count by 3s, will we get to a 10? No. Keep counting. 15. Stop. If we count by 3s, will we get to a 15? Yes. 15 is our common denominator. Extend your line. Draw 2 equal signs. Bring over your whole numbers. Bring over your fraction bars. 15 is our common denominator. Now let's make equivalent fractions. 3 times what is 15? 5. 1 times 5 is 5. 5 times what is 15? 3. 2 times 3 is 6. We've got common denominators. Now can we subtract? No. Take a look. Here's why. 6 is larger than 5. Bigger bottom, better borrow. So our subtrahend will slide over. Draw 2 equal signs. Extend your line. The subtrahend slides. Alliteration. Now, whenever we have a bigger number on the bottom, we must always borrow. We are going to borrow from the whole number. 11 becomes a 10. But what is the next number that equals 11? But we have to use the common denominator of 15. 10 and 15 fifteenths. Yes. Take the 15 fifteenths and add it to the 5 fifteenths, because all of this is equal to 11. But we can't just leave out the 5 fifteenths. That's not very nice to leave somebody out. So let's add it to it. 15 fifteenths plus 5 fifteenths equals 20 fifteenths. Okay, now we can go ahead and subtract. Remember, start by writing your fraction bar first. Bring down your common denominator, 15. Subtract your numerators. Take 6 from 20, that gives us 14. Now let's take care of those whole numbers. Subtract 7 from 10. 3. Before we can circle that as our final answer, let's always end by asking our 2 questions. Number 1, is it proper? Yes, it's proper because the numerator is smaller than the denominator. Second question, is it reduced? Yes. How do you know that? Because 14 and 15 are in counting order. Since our 2 questions can be answered with both yeses, we're good to go. All right, you will have several different problems similar to these all on the front page. But before I let you go for today, would you go ahead and turn to the back page, please? I want to go over something with you that is often missed when we have our work together in our math or on tests and quizzes. And that is on the back. I'm on section 8, problem F. Section 8, problem F. Would you turn there for me? You're going to see that up on the screen. Okay, we should all be there. Let's examine letter F together. What process are we doing? Multiplying. Are we multiplying whole numbers by whole numbers? No, we are not. We are multiplying a mixed decimal by a decimal. The very first thing you need to do is go out to the side and do your swooshing. Now, the reason why we're doing our swooshing or our parentheses is because we need to count how many digits are located behind each decimal point. Let's count. 1, 2. Whoopsie. Let's try that again. Delete. 1, 2. Put a 2 there. Let's count for the next one. 1, 2. Put a 2 there. Add the numbers that are in the parentheses. 2 plus 2 is 4. Don't forget about that 4. We're going to come back to that at the very end. I'm going to go ahead and erase what I have here so we can see the numbers a little clearer. Let's go ahead and begin by doing our multiplying by our first digit. And the first digit that we're going to be multiplying by is the 6. 6 times 2 is 12. Carry the 1. 6 times 0 is 0 because anything times 0 is 0. 0 plus 1 is 1. 6 times 9 is 54. I need to do 2 things at this point. I need to erase what I carried. Next, I need to annex a 0. Remember, annex means you're adding a 0. That's all it means. Now, let's begin with our second partial product. Let's multiply by 5. 5 times 2 is 10. Let me change it to a different color so you can see it better. Carry the 1. 5 times 0 is 0 because anything times 0 is 0. 0 plus 1 is 1. 9 times 5 is 45. Now that we have our two partial products, it's time for us to add those together. Two plus nothing, 1 plus nothing, 4 plus 1, 5 plus 5, 1 plus 4. This is not our answer. I repeat, this is not our answer. Do you remember how I said we are going to come back to that 4 at the very end? We're now at the very end, and it's time that we go back to it. That 4 means we need to have 4 digits behind the decimal. Am I going to start counting at the 5 or at the 2? At the 2. It is really important that we start counting from the right. Let's go over 4 digits. 1, 2, 3, 4. The decimal goes between the 5 and the 0. The 5 that's closest and farthest to the left. We do not need to add a comma here because those numbers are in the decimals place. Circle our answer and we're good to go. As a reminder, if we did not stop and go back and put our decimal in the correct spot, even if we had all the right numbers, our answer unfortunately would be incorrect. It's kind of like if somebody owed you $400, but they only gave you $4. That decimal point has a really important meaning and can totally change the meaning of your numbers. Decimal points are very small, but they are mighty, okay? All right, your mission for today is to complete as many problems as you can on the front and the back. We will discuss as many as you were able to do during our FaceTime, either today or tomorrow. Okay, fourth graders and parents watching, thank you so much. I hope you have a wonderful, thankful Thursday, and I look forward to seeing you again soon. Bye-bye.